From the Millersville University Weather Center, I'm meteorologist Kyle Elliott here with my 2025-2026 winter outlook. While snow lovers and fans of colder weather are probably fed up around northern Maryland, southeastern PA, and the lower Susquehanna Valley after the last few years, and honestly, rightfully so, because last winter was the fourth consecutive one with below average snowfall at Millersville University. In fact, we only received 16.5 inches of snow in the entirety of last winter season, and as you can see, most areas across the lower Susquehanna Valley did receive a general 15 to 20 inches of snow last winter. Compared to average, that's only about 50 to 70% of average. Normal snowfall in a given winter ranges from about 20 inches in southern Lancaster County upwards to about 30 to 35 inches in areas north and west of Interstate 81. So some winter climate influences that will, in essence, influence my forecast in a given winter season. First, we have the interseasonal climate influences, and these are ocean sea surface temperature anomalies in the equatorial Pacific Ocean and also in the northern and central Pacific Ocean. The equatorial Pacific SST anomalies are the base for El Nino and La Nina, and those in the northern and central Pacifics are the base for the Pacific Decadal Oscillation, or PDO. These typically change on the time scales of years, or at minimum 6 to 12 months. Then we have the intraseasonal climate influences, and these change on the scales of multiple weeks or even several months. And those are the jet stream blocking and tendencies in the high latitudes around Greenland and northern Canada. These are the NAO, the PNA, the AO, the EPO, and the MJO. A few of these I will touch on later in the presentation. And then we have the daily, weekly weather trends, etc., snow cover, ground moisture, recent storm tracks, etc. Those change on a daily or weekly basis, and they're really hard to forecast months or years in advance, so I won't really talk about this in a seasonal forecast. As we take a look at the November 3rd sea surface temperature anomalies, you'll notice this blue shading here in the equatorial Pacific Ocean. Well, when sea surface temperature anomalies are below normal, such as they currently are, that means we're in a state of La Nina. And then if you look in the northern and central Pacific, you notice this cool blob of water just south of Alaska up against the western coast of Canada and the Pacific Northwest of the United States. You'll also notice this warm tongue of water across the central Pacific Ocean. Well, that means that we're in a negative PDO phase. A positive PDO would be just the opposite of that. You'd have cooler waters in the central Pacific and then this warm tongue right along the west coast of North America and along the southern coast of Alaska. So typically when we have a La Nina present, that leads to an active storm track into western Canada and the Pacific Northwest. And as a result, a lack of big Gulf and East Coast storms. The reason for that is because if storm systems track into the Pacific Northwest or western Canada, they then dive southward across the northern Rockies, central states, northern plains, and upper Midwest. What happens is they lose a lot of their moisture as they cross this higher terrain of western North America, and they never dive far enough south to tap into that rich Gulf and Atlantic moisture. So as a result, we're left with a lack of those big storms and see more frequent minor precipitation events. The strongly negative Pacific Decadal Oscillation may contribute to a chilly pattern in Alaska when western North America with periods of milder conditions in the eastern U.S., and this is often more prominent during the second half of winter. And that's exactly what I'm expecting this upcoming winter season. So how do I usually go about making a forecast for a season such as the upcoming winter? Well, the recipe is actually quite simple. I usually look at years in the past with similar large-scale conditions as to what I'm expecting in the upcoming winter. These years are called analogs, and for this upcoming winter season, I have found 5 of them: 2000, 2001, 2005 and 6, 2011, 2012, 2017, 2018, and 2021, 2022. What you're looking at here is a chart of the multivariate ENSO index, or MEI. Essentially, this is a measure of how the atmospheric background state is responding to the ocean sea surface temperature anomalies in the equatorial Pacific Ocean, i.e. how is the atmosphere responding to El Nino or La Nina. As you can see, currently you see that the index is in the negative territory, which is indicative of that the atmosphere has already responded to this La Nina, and we're in a background state of La Nina as well. I do expect that to continue through most, if not all, of the upcoming winter season. And taking a look at the PDO index, this graph is a little bit harder to see, but you'll notice that right now we're in a very strongly negative PDO. In fact, the PDO reached a record negative value in July of this year. You'll notice that in all of my analog years, the PDO is either slightly negative or strongly negative. So it's very important that these two indices align in analog years, if that's what I'm expecting in the upcoming winter season, which I am. I do expect the PDO to also remain strongly negative throughout much, if not all, of the upcoming winter. So taking a look at snowfall in these 5 analog years, you'll generally see that it ranges from about a foot to as much as 3 feet. In 3 of the analog years, the snowfall ranged from about 24 to 39 inches, and then 2 of them, you'll notice that snowfall was 15 inches or less. When I average out these values, it comes out to about 23.7 inches. The long-term 1981 to 2020 average is 27.9 inches. So what you'll notice here is that on average, snowfall is very close to normal in this set of 5 analog years. But out of the 5, there are 2 of them here with noticeably higher snowfall totals. 29.5 inches in 2000 and 2001 and 38.6 inches in 2017 and 2018. So as a result, I'm going to kind of skew my forecast toward the higher end of this range. So I'm expecting about 20 to 30 inches of snow across Lancaster County this winter season, spanning from December through March of 2026. So this is just a simple chart of model predictions of El Nino and La Nina from last month, October of 2025. What you'll notice here is that we have dipped below that negative 0.5 threshold, so we are officially in a weak La Nina. It does look like La Nina will persist at least through the first 2/3 of the winter. We may go back into an ENSO neutral state in February or March, but overall, La Nina just seems like it's not going to get very strong this winter. So we'll be in a weak to perhaps at most moderate La Nina in December and January, but again, it should remain on the weak side. So how about the polar vortex? You know, you've heard this term in the news multiple times, pretty much every week over the last several winters. Well, the polar vortex essentially is a measure of how strong the westerly winds are. Well up above our head, about 20 to 50 miles above our head, believe it or not. So you're up in the stratosphere here, really at the top of the second layer of the atmosphere. And when these winds are stronger, you have more of a positive value here, then the polar vortex is also stronger. The dark red line here is essentially a measure of the average strength of the polar vortex in late November into mid-December. The dark blue line here is the model forecast of how strong the polar vortex is going to be over the next several weeks. All these different blue lines are different ensemble members of the model. So there's multiple different runs of the model run out, and each one of them expects the polar vortex to be a different strength. The dark blue line is simply an average of all those different solutions. What you'll notice here is that compared to average, the average of the model solutions is much weaker than normal. So that's essentially saying that the polar vortex looks like it's going to be weaker than average through the middle to latter part of December. There are reasons for that I won't get into, but I do expect that to continue throughout most, if not all, of the entire winter. When the polar vortex is weaker like this, it has a tendency to wobble around, stretch, elongate, and when it stretches and elongates like this or wobbles southward off the Arctic Circle, what happens is oftentimes you'll get these discharges of Arctic air in the central and eastern United States. Essentially, the jet stream drops southward across the eastern U.S. and it bulges northward across western North America. This feature seems to be most pronounced in the early part of the winter, the first half of the winter in December and early January, and then perhaps again late in the winter, i.e. late February into March, when we have a weak polar vortex like this. That was exactly what happened in 2017, 2018, which, not coincidentally, is one of my 5 analogs for this winter season. So as what I do here is I break down my outlook into individual months. So I have the December 2025 outlook, and then I'll show January 2026 and February 2026. What I'm doing here is compiling an average of the temperature and precipitation anomalies in those 5 analog winters. What you'll notice for December is this predominance of chilly air across the central and eastern United States, with the only areas with above normal temperatures focused on the western and southwestern United States. On the contrary, there's not really any parts of the country that look like in those analog years have saw greater than normal precipitation. In fact, most areas of the country are drier than normal in those analog years. So you may look at this and say, well, it might be cold, but it's going to be dry. Well, that's a misnomer because we typically see 3 inches of liquid equivalent precipitation in the month of December. So even if we get 1.5 inches of liquid equivalent precip and most of that falls as snow, your typical snow ratio is about 10 to 12 inches of snow per every 1 inch of liquid. So even if, say, half of that falls as snow, right there you're already looking at 8 or 9 inches of snow in the month of December. So just because I'm expecting below normal precipitation in December does not necessarily mean I'm expecting below normal snowfall. In fact, it's quite the opposite. I'm expecting slightly above normal snowfall. Typical snowfall in Lancaster County in December is about 4 to 5 inches. I could see us getting a few more inches than that this December, and that's because temperature departures I expect to be 1 to 3 degrees below normal. So it's going to be cold enough to snow during many of those precipitation events we get in December. January looks like it's shaping up to be more of a transition month. You'll notice as I flip back to December and then flip forward to January, it's essentially the whole weather pattern starting to mix up. It's kind of turning over and doing a total 180. You'll notice now that the warmest temperatures compared to average are in the northern United States, and the coolest conditions relative to average are now in the southeastern United States. Here in Pennsylvania, temperatures were generally around normal on average in those 5 analog years. Precipitation also around to just ever so slightly below normal. So as a result, I'm expecting temperature departures of 0 to 2 degrees above normal in January, near normal precipitation. A lot of that may fall as snow in the first half of the month, but then I'm expecting more changeover events and all rain events during the second half of January. As a result, my snowfall forecast for the month is 3 to 6 inches. And then moving forward into February, this is a very typical pattern in a La Nina winter. What happens is the core of the cold air shifts into the central and western U.S., and you tend to get a northward bulge in the jet stream over the eastern U.S. So yeah, you'll notice the precipitation anomalies. It looks like February is probably going to be our wettest month of the upcoming winter, but because temperatures are above average, most of that precipitation falls as rain or a mix of rain, sleet, freezing rain, and snow. So as a result, I'm expecting snowfall in February to actually be slightly below normal. February is typically our snowiest month with around 9 inches of snow here at Millersville. Right now I'm expecting that snowfall in February to be about 4 to 8 inches. So taking a look at everything as a whole, aggregate temperature departures for DJF, I'm expecting temperatures to honestly be near to ever so slightly above normal. You'll notice the average of the 5 analog years temperatures were about a half degree above normal on the winter season as a whole, and that's about what I'm expecting this winter. Essentially, our chilly December is going to be offset by our mild February. As far as aggregate precipitation departures, again, the drier conditions in December may be offset by slightly wetter than normal conditions in February. As a whole, things look pretty much right about average for this winter season. So here are the highlights. La Nina and a strongly negative PDO will be major factors this winter, and as a result, the storm track will more often be to our northwest than to our southeast, with a lack of strong coastal systems and higher number of weak moisture-starved systems. I expect several changeover storms where precipitation begins as snow or sleet and then transitions to ice or rain, with more all-snow events centered off to our north and west, such as in the Ohio Valley, New England, and across the Great Lakes region. The exception to this could be during that first part of winter, when we have this persistently cold 2 to 4 week period between December 10th and January 15th. During that period, I expect more all-snow or mixed precipitation events here across the Lower Susquehanna Valley. Going along with that colder period, there is a chance for a significant ice storm, especially before mid-January and perhaps right around the holidays. I do expect the holidays to be one of the coldest portions of this upcoming winter. So overall, though, in aggregate, due primarily to that flip to milder conditions in February, I expect the coldest conditions as a whole this winter to be centered in the northern and northwestern United States, with the milder conditions to be centered across the southeastern U.S. I am concerned for a flip back to winter in March. I mentioned that earlier with the 2017-2018 winter season. What happened is the polar vortex weakened dramatically in February of that year, and then effects at the ground were felt about 3 to 4 weeks later. And as a result, we flipped back to a colder and stormier pattern in March, and there were actually 3 to 4 nor'easters that impacted the northeastern United States in March of 2018. I don't expect it to be that significant this upcoming winter, but there could be one last gasp of winter in March where we potentially do see a 4 to 8 or a 6 to 10 inch snowstorm. So in aggregate, temperatures from January, February, and December will be 0 to 2 degrees above average. Again, my total snowfall forecast for winter will be 20 to 30 inches in Lancaster County, with a lower than average risk of a major 12-inch plus snowstorm. Well, that will do it for my 2025-2026 winter outlook. I will leave this video and the written version of the outlook posted on the Weather Information Center website till March 1st. Let's see how I do.